Hello engineers, welcome to the new video of the course, and in this particular video we are going to see the concept of power. Okay, so first of all what we'll do, we'll just read its definition, we'll try to understand its formula, and then we'll proceed further that what exactly power means. Okay, so this is the definition, that is energy consumed or delivered per unit time is known as power. Okay, I know most of you guys, you don't understand anything by reading this particular sentence. That's absolutely fine. Okay, so this is what the formula is, that is energy per unit time, and this is the unit, that is joules per second, or we call it as watts, or some people call it as, pronounce it as watts. That's absolutely fine. Okay, so this is the unit of power. Okay, great. I know you didn't understood anything, that is absolutely fine. We'll proceed further and we will just focus upon its unit first. So the unit of power is what? So the unit of power is nothing but joules per second, right? This is what we saw, right? This is what it is mentioned, right? Energy per unit time, energy is nothing but joules, okay, and time is represented in seconds, right? So joules per second. Great. Now if you could recollect the unit for voltage, if you could remember in the previous session when we saw the formula for voltage, it was what? Work done. Okay, work done divided by Q, right? So that was nothing but J by C, J by C. Okay, and also if you could recollect the formula for current, what was that? It was nothing but I is equals to Q by T, Q by T, that is nothing but coulombs per second, right? And now if you look at this particular two units, so if you look over here very clearly, see, in power we want J at the numerator. In case of voltage we have J at the numerator. That's great. Okay, for power we have seconds in denominator, and when it comes to current we have seconds in its denominator, right? So what if, let's say if I do it in this way, if I somehow try to equate this entire thing in this way, that is joules per coulomb, I mean if I try to multiply it, okay, into coulombs per second, so you can clearly look over here, they both are getting cancelled, and what we essentially get is this, that is joules per second. So what does that mean? What is your conclusion based upon that? So that means the formula for power will be, that is power is equivalent to V times of I. Why? Because if you see, this is the unit for what? Voltage, right? Times of, this is unit for what? Current, right? Voltage times of current. So this is the actual formula for the power. Okay, this is the actual formula for power. I hope you are able to understand this. Okay, I really hope that you are able to understand this. Let me just write over here the formula for power. So the power is nothing but voltage V times of current I. Okay, so this is what we saw, and that's why I always say, whenever you see any sort of things, first of all take a lot of time for observation, right? What we did, we just observed this particular thing, okay, and based upon that only we deduce this entire thing. I hope you are able to understand this. It's pretty simple, right? It's pretty simple. Okay, so now let me just write it in short form. So power is equivalent to V times of I. Based upon unit only we deduce this particular formula. Okay, so let me just highlight this particular point. Okay, now I know most of you guys may say, okay sir, we understood this entire thing, this entire scenario, but yet we are not clear that what exactly is the power. Well, for that we need to take one example. Let's say I have this particular circuit, I have connected a voltage to a fan, okay, this is the load, okay, and let's say the voltage is delivering 2 ampere of current, or rather there is 2 ampere of current flowing in these two elements, okay, that is in between voltage and this particular fan we have current of 2 ampere. Okay, and the voltage that I'm applying, it is 5 volts. Okay, so based upon that, what logic will you decode? Okay, based upon this, what logic you will decode? It's pretty simple. What you will say is that power is equivalent to V times of I. Okay, so that will be voltage is 5 volts times of current is 2 ampere, so that becomes 10 watts. Okay, I hope you are able to understand this. So what does that mean? That means this particular fan, it is consuming 10 watts or 10 watts, whatever that is, 10 watts. Okay, I know still few of you all guys, you all guys may not be clear of what that means. That is nothing but 10 joules per second. Still some of you all guys may not be clear about this particular entire scenario, that what exactly is happening over here. Well, for that, just look over here. So you see 2 ampere is nothing but what? 2 coulombs per second. So what does that means? At any point 2 coulomb of charge is passing through the fan in 1 second. So there is this particular through this particular fan 2 coulomb of charge is passing per second, right? This is what it means, right? I have clearly mentioned that 2 amperes is nothing but 2 coulomb per second. Okay, also we have 5 volts, right? Because you see we are applying 5 volts across this particular fan, right? So what does that mean? 5 joule per coulomb, that means what? 1 coulomb of charge is giving 5 joule of energy to the fan. Okay, so let's try to write a few of the things that we can see over here. The first point that we can see is that 2 coulomb of charge is passing through the fan. 2 coulomb of charge is passing through the fan in 1 second, right? In 1 second. The second point that we saw was this, that is 1 coulomb of charge is giving or is providing, whatever you want to say, how much energy? 5 joule of energy, 5 joule of energy to the fan, okay. 1 coulomb of charge is providing 5 joule of energy. Okay, so what does that mean? That means, whatever the electrons that are flowing from this entire circuit. Okay, so let's say if I have 2 coulomb, right? 2 coulomb of electrons, right? Since my current is moving in this particular direction, so the electrons will flow in this particular direction. Okay, so 2 coulomb of electrons, they are flowing in this particular direction towards the fan. Obviously they will come out from this particular path. Okay, and we all know 1 coulomb is nothing but what? 1 coulomb is nothing but 6.25 roughly into 10 raised to 18 electrons, right? So you just need to multiply it with 2, so you will get 2 coulomb of charge, right? So when you multiply this thing with 2, you will get 2 coulomb of charge. You just need to multiply it with 2. Okay, great. So that means this many electrons, they are what? They are coming towards the fan. Okay, and the moment they come towards the fan, they are losing how much? They are losing 10 joule of energy. Okay, I hope you are able to understand that. They are losing 10 joule of energy. Okay, they are losing 10 joule of energy per second. This is what it means. Okay, so let me just write this particular point. So let's say at 0.5 second, okay, at 0.5 second, 1 coulomb of charge approaches towards the fan, and they emit 5 joule of energy. Okay, or they lose 5 joule of energy. In next 0.5 seconds, another set of 1 coulomb of charge come, and they lose 5 joule of energy. So in all, how many coulomb of charge came in 1 second? So let me just write over here. This is very, very important point. In all, in 1 second, total 2 coulomb of charge came. Okay, and this 2 coulomb of charge, they delivered 10 joule of energy in how many minutes, or in how many seconds? In 1 second. So this is what means. Okay, that means power is nothing but how much energy is being delivered to the load or to the resistor that is connected to the circuit. So you see, in our case, in this particular circuit, the resistor or the load is nothing but the fan. Okay, because fan is consuming certain what? It is consuming certain energy. Okay, so that consumption is known as what? Power. I hope now this particular part is very, very clear. Okay, so if you could remember, if you could remember that I clearly mentioned, when the electron comes, let's say if this is the voltage, right? If this is my voltage, I'm just drawing it roughly. If the electrons come, I hope you can recollect this particular entire scenario. So if this electron comes towards the voltage, so this electron gains what? Energy, right? Electron gains energy, right? We saw that with the help of the example. I hope you could remember that, where I explained you that you are the culprit who is, picking up the ball and inserting in the above pipe system. So you could, I hope you could remember that we have two pipes set up. So you are picking the ball from pipe 1 and you are inserting the ball in pipe 2. So same thing this particular voltage is doing, but what exactly this fan is doing? So let's say if I have this particular fan, I'll just draw it roughly. So this kind of fan, right? So the electron is approaching towards this particular fan, right? The electron is approaching towards the fan and they are leaving it, right? So whenever the electron strikes this particular fan is not exact fan, but that particular system. So this electron, what exactly is happening? They are losing certain energy, losing the energy, or rather what I can say, this particular fan, it is gaining certain energy from that particular electron, gaining energy. Or in other words, what I can say, this voltage, okay, with certain amount of current that flows over here, check this side, this voltage and current, they are responsible to provide certain energy to the fan. Okay, if I cut the voltage from the circuit, so there won't be any current, right? Okay, so that's the entire scenario. If I let's say cut the wire which is joining this particular fan and a voltage, so there won't be any current, right? So your power is totally dependent upon what? Voltage and current. I hope this particular part is crystal clear. Okay, so power is nothing but the amount of energy that is consumed per second. That's it. It's very, very simple. Okay, I hope this particular part is crystal clear. So it is represented in watts. Okay, so 10 watt, or some people call it as watts. That doesn't matter. You just need to understand the concept. That's it. Okay, but I hope you enjoyed this particular session as well, and you understood the power in some different way, in some different manner, because most of the books, they will just explain you the concept very bluntly. You just need to read it. Okay, some guys, they just mug up the entire sentences, right? And I really don't like that kind of approach, right? Whenever you learn any sort of stuff, first of all, what you need to do, you need to observe, as we did over here. We just observed the unit. Based upon that, this is what we deduced, and the moment we deduced this particular thing, we what we did, we just did its postmortem. We just understood that what exactly is happening inside the circuit, and based upon that, we deduced this entire thing. Okay, and now I really hope that you understood each and everything. Okay, but still, if you have any doubts, if you're facing any difficulties anywhere, you can ask me in the communication section. I'll be happy to help you out there. So thank you for listening me patiently. I'm ending this video over here.